Sana.
Hello everyone, myself Ritika Chetipelli from CSC branch section D. Today I am going to present a PPT on topic called an essential object oriented programming language and its implementations. Of course, object oriented programming system. Introduction to Initial Object Oriented Programming Language IOPL. This presentation explores the concept of an Initial Object Oriented Programming Language IOPL and its implementation. We will develop into the principles of object oriented programming, the significance of IOPL in modern software development, and its practical applications. Understanding IOPL is crucial for developers aiming to enhance their programming skills and adapt to evolving technology landscapes. What is object programming actually? Core principles. Object oriented programming is based on four core principles: encapsulation, inheritance, polymer- polymorphism, and abstraction. Encapsulation restricts access to certain components. Inheritance allows new classes to adopt properties of existing ones. Polymorphism enables methods to different things based on the object, and abstraction simplifies complex systems by modeling classes based on the essential characteristics. Benefits of OOPS. Developers can create modular programs that are easier to debug and extend. This approach also enhances collaboration among teams, as different developers can work on separate objects without interfering with one another codes. OOP promotes code reusability, scalability, and maintainability by organizing codes into objects. Real world applications. OOP is widely used in various domains, including web development, game development, enterprise applications, software development, app developments, etc. Languages like Java, C++, and Python leverage OOP principle to create robotic applications. For instance, in gaming development, OOP allows for the creation of complex characters and environment that interact with them. Defining initial object oriented programming language. Concept overview. An initial object oriented programming language IOPL is designed to introduce fundamental OOP concept to novice programs. It serves as a stepping stone for learning to grasp the basics of OOP before transition to more complex languages. IOPL emphasizes simplicity and clarity in syntax, making it accessible for beginners. Key features of OOPS. IOPL typically includes features such as basic data types, control structures, simple objects definitions. It may also support essential OOP concepts like classes and objects, allowing users to create and manipulate objects easily. The language is often designed to lightweight, focusing on teaching rather than performance. The primary audience for includes students, educators, and self-learners who are new programming by providing a gentle introduction to IOPL, aim to build a strong foundation that prepares learners for more advanced programming languages and concepts. Adoption of object-oriented program in a graphical representation method. Java, it can be understandable 40%, whereas C++ 30%, Python 25%, Ruby 20%, and C hashtag 15%. Implementing IOPL. Key considerations. Designing syntax. When implementing IOPL, designing a clear, interactive syntax is crucial. Otherwise, it does not exist any program. The language should minimize complexity while allowing users to define classes and objects easily. For example, using straightforward keywords and structures can help beginners understand the language without feeling overwhelmed. Educational resources. Providing comprehensive educational resources such as tutorials, documentation, and example projects is essential for effective learning. These resources should guide us through the language features and best practice, enabling them to build the confidence as they progress in their programming language journey. Community support. Establishing a support community around IOPL can enhance the learning experience. forums, discussion groups, and online platforms wherever users can ask questions and share knowledge, faster collaborations, and motivations among learners. This support network is vital for beginners who may encounter challenges. IOPL development process. IOPL development process is shown in a pie chart. Language features, then design syntax, then educational researches, and gather information and create a program. Challenges in IOPL implementation. Balancing simplicity and functionality. One of the main challenges in developing IOPL is balancing simplicity with functionality. While the language should be easy to learn, it must also provide enough features to be useful. Striking this balance is crucial to ensure the learners do not feel limited in their program capabilities. Maintaining engagement. Keeping learners engaged in other challenges. IOPL must incorporate interactive elements such as coding exercises and projects to maintain interest. Gamifying techniques such as rewards for completing tasks can also enhance motivations and encourages continued learning. Adapting to feedback. Gathering and adapting to user feedback is essential for the continuous improvement in IOPL. Developers must be open to suggestions and willing to make changes based on user experience. This iterative approach ensures the language evolves to meet needs of its users effectively. Users' feedback on IOPL is shown in a pie chart, as you can see in this slide. Feature directions for IOPL. Expanding features. Feature iterations of IOPL should focus on expanding features to include more advanced OOP concepts, such as interfaces, expectation handling. This expansion will provide learners with a more comprehensive understanding of OOP and better prepare them for transition to more complex languages also. Integrations with modern technologies. Integrating IOPL with modern technologies such as web development frameworks and cloud services can enhance its relevance. By allowing learners to build real world applications, IOPL can demonstrate the practical application of OOP principles, making the learning experience more impactful. Global outreach. To maximize its impact, IOPL should aim for global outreach by providing multinationality support and localized resources. This approach will make the language accessible to a broader audience, forecasting a diverse community of learners and contributes. Key concepts in IOPL. Encapsulation, inheritance, and polymorphism is mainly used in the IOPL language. Encapsulation is the bundling of data and methods that operate on the data with a single unit or class. This concept helps protect the integrity of the data and restrict access to it, allowing for controlled interactions. Inheritance. Inheritance allow a new class to inherit properties and methods from an existence class. This promotes code reusability, establishing a hierarchical relationship between classes, making it easier to manage and extend code. Polymorphism. Polymorphism enables methods to perform different functions based on the object that invokes them. This flexibility allows for dynamic method resolution, enhance the adaptability of the code. Conclusion and next steps. In conclusion, the initial object-oriented programming language serves a vital educational tool for aspiring programmers by focusing on core OOP principles and providing a user-friendly experience. IOPL can effectively prepare learners for more advanced programming challenges. Future developments should prioritize feature expansions, integrations without modern technologies, and global outreach to maximize its impact. Embracing these strategies will ensure that IOPL remains relevant and beneficial in the evolving landscape of software development. It's a core implementation involves object-oriented programming implementations, classes and objects. A class is a blueprint for creating objects. It defines the properties, data, and behavior methods that all objects of that type will have. For example, a car class might have a properties like color and make and methods like start and stop. An object is an instance of class, a specific realization of blueprint. You can create multiple objects from the same class, each with its own unique state. For instance, my Toyota and my forward cloud would be two separate objects created from the car class, each with its own color and make. Encapsulation. This principle involving mint bundling as data, as I already told in the above slide. Inheritance allows a new class to inherit properties and methods from an existing superclass. This promotes code reusability and creates a hierarchy between classes. For example, electrical car class could inherit from the car class and add its own unique properties like battery levels and many more. These are the OOPS language, OOPS language, OOPS language implementations. Thank you.